Welcome to The Explainer. Today, we're going to pull back the curtain on this invisible competition that's creating some of the most mind-blowing AI images you've ever laid eyes on. It's really a story about a digital forger and a critic, locked in this constant duel to achieve perfection. So, let's start with this question. Can an AI actually learn to lie perfectly? Let's really dig into that, because the answer reveals the secret behind one of the most powerful forms of artificial intelligence. You see, it's not just about making something new. It's about learning how to create something so incredibly real it becomes impossible to tell from the original. Because, these hyper-realistic images, they're not born from just one single brilliant AI. They're actually the result of a constant, high-stakes battle between two very specialized networks, and each one has a completely opposite goal. This whole competitive system has a really cool name, a Generative Adversarial Network, or just GAN for short. And that word adversarial is key. It's right there in the name. These two networks are basically opponents in a digital game. And it's this game that pushes them both relentlessly toward perfection. So, let's meet our two rivals. On one side, you've got the generator. Think of it as our brilliant art forger. Its whole mission in life, to take random digital noise and just sculpt it into a masterpiece that looks totally convincing. And on the other side, you have the discriminator, our super sharp-eyed art critic. Its only job is to spot the difference between real art and the forgeries. So, how does this rivalry actually play out? Well, it all unfolds through a process called adversarial training. And look, this isn't just a single showdown. It is a relentless, non-stop cycle of creating, judging, and improving. Okay, so it's this endless four-step loop, right? First, the forger makes a fake. Then, that fake is shown to the critic right alongside some real art. Step 3, the critic makes its call. Is it real or is it fake? And here's the most important part, step 4. The forger gets feedback. Every single time it gets caught, it learns from its mistakes and it tries again, getting a little smarter, a little sneakier, every single time. Now, if you want to get technical about it, they're playing what's called a mini-max game. And the idea is actually pretty simple. Each player is trying to minimize their own mistakes, or their loss. The forger wins if the critic messes up. The critic wins if it spots the fake. And this constant push and pull is what forces them both to get more and more sophisticated. So when does it all end? Well, like the quote says, it's when the critic cannot reliably tell real data from fake. They basically reach a stalemate. The forger becomes so good that the critic is pretty much just flipping a coin. It's only guessing right about half the time. And at that moment, the forger has done its job. It's created a near-perfect copy. But here's the thing. This whole adversarial competition, it's not the only way for an AI to learn how to create stuff. There's a totally different philosophy, a whole other method that's less about being a forger and a lot more about being, say, a careful apprentice. This other method uses something called a Variational Autoencoder, or a VAE. Now, instead of two networks competing, a VAE is just a single network that has two distinct parts. So you can think of it less like a forger and a critic, and more like a diligent art student, carefully studying the masterpiece so they can learn to recreate it perfectly from memory. So the VAE process is kind of like a two-step dance. First, a part called the encoder looks at a real image and boils its essence down into a simplified code. It's like it's creating a super condensed summary. This summary lives in this compressed form they call latent space. Then the decoder takes that little code and tries to rebuild the original image using only those instructions. The goal is simple. Make the reconstruction look exactly like the original. Okay, so we have the competitive forger, that's the GAN, and we have the careful apprentice, that's the VAE. Both of them can generate images, but their methods are like worlds apart. So how do the results actually stack up against each other in a showdown? So which one is better? Yeah, that is the million-dollar question in generative AI. And the answer, as is so often the case in tech, is, well, it depends. There is no single best model here. There's really only the right tool for the right job. This chart here really breaks down the key trade-offs. Let's just look at a couple of things. Notice under structure, right? GANs use two competing networks, while VAEs use that single encoder-decoder setup. And this directly impacts their training style. GANs are adversarial, it's a fight for who's best, while VAEs are all about reconstruction, trying to minimize the error between the original and the copy. This one difference leads to totally different strengths and weaknesses. And you can really see that difference in the quality of the output. A GAN image is typically just sharp and photorealistic. I mean, that's what you get from that intense competition. But that same fight can also make them really unstable to train. A VAE image, on the other hand, might be a little bit softer, maybe a touch blurrier, but the process to create it is way more stable and predictable. This kind of powerful technology, especially the hyper-realism you get from GANs, is already changing our world. It's bringing a future that's filled with both incredible promise and, frankly, some serious peril. We're talking about amazing opportunities to create, right alongside some very real risks we have to figure out how to navigate. So on the promise side, the potential is just immense. GANs can create synthetic data to train other AIs, which is absolutely vital when real-world data is hard to come by. They can take a low-res image and make it sharp. They can transfer the artistic style of, say, a Van Gogh onto one of your photos, and they can even just dream up entirely new faces and landscapes from scratch. But that same power to create is also a huge peril. This is the technology that's the engine behind deepfakes, and those can be weaponized for misinformation, for targeted harassment, and for political propaganda. It really challenges our fundamental ability to trust what we see with our own eyes. And this leaves us with a final, pretty provocative question to think about. If an AI can forge a perfect copy, what is it that makes the original real? As this line between what's real and what's synthetic just keeps getting blurrier, how are we going to define authenticity? I mean, when the forger is perfect, the value of the original, and maybe even the nature of truth itself, really comes into question.